Hello again. This is just a video here showing you the semi-automatic tool change. As I say, I'm not certain that's the best analogy, but it's what we're going to use at the moment. So basically what we're going to do is, you can see that the tool height is, wireless tool height is sitting on a plate, which we're going to use as our material that we were going to machine. We've got a tool in there already. Now what we can do is, we just go over a couple of little things here. Maximum distance for the Z to move down is 30 millimeters. So basically the tool has to be within 30 mil of the top of the wireless tool height. It's going to move at 200 millimeters a minute for fast probing, and then it's going to come back up, and then it's going to do 20 millimeters a minute for the final. We normally use 10 millimeters, but for this demonstration there's not a huge amount of difference, but we're going to use 20. The retract height here is just basically that after it's probed, it's going to come 10 mil off the surface of the wireless tool height. And these other ones at the moment, they're not used. They are for future development. Okay, so here you can see at the moment we've got a value in here, which is arbitrary because it's not being set up. We've referenced the machine is ready to go, everything is set up. So what we're going to do, the first thing we're going to do is auto tool chip 0, and that's just a routine that's written in here, and that's going to set the probed offset to 0 so that we can start this, so we've got a clear reference from it. So let's do that first. Oh sorry, one last thing is, here you can see, as we showed in a previous video, you've got your gauge height here set. The more accurate this is done, the better. We would suggest that when you've done this, you would always have it a little bit lower than necessary. So obviously if it's too high, or the reading is too high for the Z-axis, it's going to go right into your material. So you're better off when, for example, when you're touching the surface, maybe you're 0.1 of a millimeter or 0.05 millimeters minus, and so there. But as I say, we've covered that in the previous video. So let's just do an auto tool change, auto tool 0, sorry. First thing it's going to do is ask us that we check that basically that the wireless tool height is working. We say yes, and then it's asking us, is everything set up and underneath, and we're saying yes. And we're going to say tool 1 for no real reason apart from typically that's what we'd start with. You can see that the tool number up here has changed to 1. It's now probing slowly and then come back up. Again, it's now 10 mil above the surface of the wireless tool height. So now what we're going to do is, we're going to remove this, and we're going to put this where we've defined. We showed in another video, we've kind of defined. The reason we've defined it here, it just makes sense that it's easy to do, but you can have it anywhere on there. And what you can do, if you want to, is you could just do a little reference part, or you could actually just write on it with a Sharpie so you know where to put it. Okay, so now what we're going to do is, we're going to now, just to show you here, we've already done it. So basically what we're going to do is, we're now going to tell it that we want to now use tool 0. So what we've done is, we just press enter, just press tool 0, sorry, just come up here, press tool 0. Now the first thing it does, it goes up here. Now we've already cut, typically we would have already used tool 1 to cut something, the surface or skim or whatever. But now what it's done is, it says, is the wireless tool height ready and underneath the surface, which it should be because we've decided and set that up previously. So we're going to say yes. Now it's going to come down at about 200 millimeters a minute. As I say, in the previous video, we could change this value here so it doesn't go right up the top and take so long. And also we might be looking at here doing it that it comes down fast for a certain amount of time and then goes back to thing. But we're not certain if that's a useful feature or not, so we will consider it in the future. Again, if you've already skimmed the surface, you don't have a zero anymore when you change tools, so obviously this is quite critical that you can do this. It'll make life a lot easier. Right, so now what it's done is asking us to change the tool. It's just gone up to a safe position. Now what we've done is, if you look here, I'll take this out. To stop having to change collets and everything else, what we've done is, we've basically just got these chucks here. These were bought from Amazon. They're not very high quality. The run out is terrible, but it's just for demonstration. We will hopefully be stocking some high quality ones. That means you can have all your tools predefined. And you can see here we've got one with a lot different, so obviously the collet is a different size, and what we can do is just push it in and lock it in, because so we could, which is a cheap way of doing this, because obviously there is specialist equipment that does this, but it's quite expensive and a lot of them don't take a high load. So what we'll do is we'll say now is it's just doing now what it calls a sanity check, which just makes sense. Basically this is to make sure that the tool is tight and you're happy to proceed. Now the previous tool, you can see this is all these values in here are machine coordinates, which we get from when we reference the machine in the first place. Now what it's going to do is touch off this. It's then going to put a new value in the probe, so that it basically now it's gone to minus 66 approximately. Then basically it just goes back to the original position. Now this would normally be running in a program, you know, in a G-code file, and you'd have the tool changes there. But what we're doing is we're just doing it for simplistic things. We're just using MDI functions to replicate an M6. So what would happen there is you can come down and you can see that before the other tool was 0. Well, we didn't show it, but we did show it on a previous video. And you can see when we're coming down, you can see that this tool is substantially different in length. But we can come right down and we can come to what we would normally do is if we'd set the gauge height to the right thing. Also, if you're cutting multiple pieces of the same piece, what we would recommend is that you start cutting at 0.3 positive, and then 0 should be the surface. That means if you're cutting multiple pieces, they will all vary in thickness. So on some of them they can be thicker, so the tool would hit the surface, and obviously if it's shorter it'll take longer. So if you've got a small thing in your CAD/CAM software, which is what we do, typically we have 0.5 millimeters, because we'll cut lots and lots of pieces on a jig and we'll just keep replacing the new raw material and it just cut. So you can see here it's showing there. So what we can do is we can come down 0.1 of a millimeter, and you can see that we're very close to being on the 0. So we can come down a bit lower. And you can see this is a bit higher than it should be, because we did when we set the gauge height, it's slightly above it. So when it's at 0, it's just going to be just a tiny bit above the surface. I think we've set it so that it's about 0.1 millimeter higher than the absolute 0. But you can set that up by fine-tuning the gauge height and making that the way you do. All this is basically to do is allow you to change one tool to another tool without having to zero it. And sometimes when you're engraving or you're machining, you no longer have, you might have skimmed the top surface or you might have engraved it. You might actually no longer have a flat surface or a surface that it was the original zero to set off your new tools. Maybe a bit too much information for a short video like this, but I hope you enjoyed this video, and if you look out, we will be setting up some new videos in the very near future. Thank you very much for your time and watching.